All right, so on this here, we're doing a button now, and it's going to require some breadboarding. So what I did is I just went here to Arduino, and I grabbed this breadboard one right here. Then you're going to have to go to Basic and grab a button, 2 resistors, an LED, and set it up like this. So here's a breadboard. All they do is they take the 5 volt and the ground, and they run it over here to the ground and the 5 volt. And of course, they spread this wire here to the other side here, just in case you need them over here.
And in the little circle and then the outer line of the circle.
And this right here, this wire right here is for negative, and this one's positive. Same as this side right here, it's spread out. And then we got your 2 resistors right here. And then we got our LED. We got our button. And then we got wiring. And let me explain the wiring real quick here. So I'm using two input outputs. These are called input outputs because they can be either one, right? So I'm going to use this as an output, and it's going to go here to number 20 for me. Oops, I put a wire there on accident. And it goes here, and then it goes to the positive side of my LED. And then the negative side of my LED just goes here, and goes to the negative. So the negative side is always negative. And when I send a positive out of this 7, because it's an output, if I send it out, it's going to turn this LED on. If I send a negative over here, of course, negative and negative won't turn it on. So I could turn it on and off, sending the outputs from 7. 2 is going to be an input today, because I'm going to send the signal in. And right now, it's going to be getting negative. And because this button right here, this is how it works. This wire right here, when I push this button, the wire from here goes this way. Okay? The wire from here goes this way. They cross each other, okay? When you do not push the button, electricity from here automatically goes here. And this electricity automatically goes here, always, even if you're not pushing the button. So let me explain what's happening now. So I'm not pushing the button right now, and we got negative, negative, and negative is going through this resistor. This resistor right now is 1K, and that should be good. That's 1,000 ohms. You could do 2,000 ohms. It doesn't really matter. So we're putting this little trickle of negative right here. It's going through a resistor. It's just a little trickle, and it goes here. It's automatically going to go here, and it's going to go here, and it's going to go into 2. So right now, 2 is low because I'm not pushing it. So I'm not pushing it, so the input's going to get a low signal. How does it get a high? When I push this button right here, when I push the button, this positive over here that's on here all the time is going to cross over here. And yes, some of it will trickle back this way and short out. In other words, it's kind of just get wasted. But it's through a resistor, so hardly anything's getting wasted. If you want less wasted, change that to 2K then. But so some of it does go backwards and gets wasted, right? Because this is positive. Remember, current travels from positive to negative, so it's going to travel back up here. But who cares? We don't care. The most of it's going to go this way. It's over flooding. There's no resistor here, so it's going to flood positive here. When I push the button, it's going to cross over diagonally, go here, and it's going to send a high. The positive side is the high side, and it's going to send a high to our 2 input. So looking at the code, the very first thing I need to do is, and let's see if I can zoom in here a little bit, is I'm going to set pin mode 7 to output. That's where my LED is. And pin mode, no, not 13. I'm using pin 2 as an input for the button. So right here, don't always add comments for everything. So sets the LED pin to output, because that's my LED pin, right? Pin 7, and sets the button pin to input, because it's listening to the button, seeing if I'm pressing it or not. So it's an input. And if I want to do something super simple, I say if, and then parentheses. I have to put the condition. If digital read. Digital read means it's reading digitally the pin, and I read pin 2 is equal high. Equal. That means it's comparing. Is it equal? When you put one equal sign, you're telling it to be equal. So when you say LED pin equal high, you're saying, hey, make it high. This one right here is saying equal. It's saying if these are the same, it's comparing them. If they're the same, then we're going to put a curly bracket, enter, and then a close curly bracket. So all my code's gonna go here. If it's high, I'm gonna say digital write. So reading is when it's an input, writing is when it's an output, right? Digital write, pin 7, high. In other words, turn my LED on, right? So I'm gonna say turn LED on. And then here, I'm going to say else, open curly bracket, close curly bracket, digital write, pin 7, low, I put a space here, low, and then semicolon, and I say turn LED off. Else just means if this thing is true, do this. If it's not, that's what else means, do this code right here. So this should work, except I might have some errors here, so let's just see what happens when I start simulation. Yeah, I did something here. Low. Oh, I put low as L-O-W, but it has to be all uppercase. I think you could also put 1 here and 0 here. I think that works, but I'll try it in a minute, but let's see. Oops. Start simulation. Let's see if I made any more mistakes. No, that's it. I made no more mistakes. Isn't that cool? So let's see if this works then. It works. When I push the button, it works. Look at that. So look at the LED. When I push it, it works. When I let go, it doesn't. See? And, we could probably just, honestly, a button and an LED, we could just take the button and run it to the LED directly. You don't need a smart computer to do this. But we are using one. So we're setting a signal into our smart processor, telling it that if I push it, send an output high to here, otherwise don't. Of course, we could just literally I could probably just run this wire over to this resistor and just send it, right? Because this is high or low. But the whole point of this is just to show you that we're using an input and an output, and we're coding with an if-else statement. And so if you look at the if-else statement, this is how it works right here, okay? So pin mode 7, pin mode 2, and that's pretty much it. Right here, you can put a note 2 right here. Let me stop the simulation, and we can add a note something like this says, check if pin 2 is high, right? That's what it's doing. It's if digital read 2 is high. The cool thing when you digitally read, you just have to put the pin number. When you digitally write, you have to put the pin number and what are you writing. Do you want it to write high or low? But on digital read, you just put the pin number because all it's doing is checking that pin and seeing if it's high or low at that moment. And that's all there is to it, folks.